we have seen that this correlation and covariance are measures of linear relationship or linear association between two numerical variables. It measures the strength of a association. So, when I say that the association is a linear association, the next natural question to ask is, can I summarize this linear association through a mathematical equation? In particular, the question we are asking is, can this linear relationship be summarized through an equation of a line? So, the question we are asking here is, when I am saying that x and y are numerical variables and they have a association which I expect to be linear, then the next question we are asking is, can I describe that association using the equation of a line? If yes, then how do I compute this equation of a line? The mathematics behind coming up with an equation of a line is beyond the scope of this particular course. You will be learning about how to come out with what we call the best line of fit in your future courses. But what I want you to see at this point of time is, yes, the relationship can be summarized. How do I summarize this? So, let us go back to our Google Sheets. So, you can see that I start with my first data here, which has been my size versus the price. Okay. I go to this data set. So, how do I find the equation of a line using a Google Sheet? So, the first step is you open the scatter plot. So, I first go and I insert a scatter plot, okay, and this scatter plot is what I have here. So, first I go and I insert the scatter plot. So, the next step is under the customize tab. So, I have my scatter plot here. This is the scatter plot of size versus price. Okay. Size is my explanatory variable, price is my response variable. Under the customize tab, click on series. So, under the customize tab, I click on series here. Now, within this, click on trend line. I clicked on series, I click on trend line. So, you can see a blue line which passes through my points. Okay. Now, the next thing is this trend line. So, the question we asked is, can I capture this linear relationship using the equation of a line? I can see that I can fit a line through the points, passing through the points. Okay. Now, further, if I want to know what is the equation under the label tab, so within this I have a label tab. Under this label tab, click on use equation. So, it gives me the equation. You can see here the equation states price equal to 30.5 into x, x here is my size plus 36. This is of the type y equal to mx plus c, which all of us know is the equation of a straight line. Now, further I can also ask it to report this r square. So, it gives an r square of 0.647. What is this r square capture? This r square actually captures the proportion of variance in my data set that is captured by this line. Again, to go into the mathematics of this r square and how to derive it is beyond the scope of this course, but r square basically is also a measure of how good a fit is this line. This r square takes the values. So, this r square is also referred to a goodness of fit measure. It is an r square. So, this takes values between 0 and 1. The closer it is equal to 1 says that my fit is a good fit. The closer it is to 0 tells me that my fit is not a good fit for my data. Okay? Okay? So, now let us look at what is this R square for different examples which we have looked. In the first example, this is what I have demonstrated just now. I have price which is my y, the response variable is 30.5 times x plus my 36. So, the slope of this line is 30.5. You can see that the slope is positive and your R square is 0.647. Recall my correlation coefficient was 0.804. An interesting observation is if I square this correlation coefficient. So, you can see that I computed the correlation coefficient of my first data set to be 0.804. If I just square this term, I get 0.647, which is precisely this value of my R square. So, let us go back to our data here. So, you can see that when I have a correlation which is closer to 1, my R square which is the square of this would also be closer to 1. This is about R. The first thing is my R square will only lie between 0 and 1. Okay. So, in a sense you can imagine to flip this along this 0. So, if I have a value which is here, R value here, my R square is going to be closer to 1. So, as my R goes to 0, my R square will also tend to 0. Let us look at an example to illustrate what we have just discussed. So, if I go and look at the same thing for this data set, we know about the age of a car and the price of a car. This is the next data set. Again I go and I click on a scatter plot. Again I go to my customize option. Under series I plot a trend line and again I ask for an equation with a R square. So, here what you notice? You notice that the price is minus 0.694x plus 9.03 with again an R square of 0.855, which is price equal to minus 0.694. So, my slope of the line is negative, which is 0.694. Okay. The intercept is 9.03. Okay. And then we also see that the R square is 0.855, even though your R was minus 0.92. So, my R in this case or my correlation in this case was actually here. Okay. The correlation was closer to minus 1, it was a very strong negative linear relationship. My R square is closer to 1. Okay. So, you can see that this goodness of fit measure takes a value between 0 and that, but it does not tell me the direction of the relationship. For the direction, whether it is a positive relationship or negative relationship, I either look at the correlation coefficient or the sign of the slope. In this case, the slope is a negative number. Now, let us look at the third example. The third example, my R was very negligible. So, it says that almost no relation. It is giving me the equation of a line, but what you notice about this line is it is almost parallel to my x axis, but and your R square is closer to 0. So, when your R square is closer to 0, the goodness of the fit measure is also very low. So, when your R square is close to 0, it quantifies the strength of the relationship, and you can say that my line is not actually describing this association very well. So, in summary, what we have looked at is how do we obtain the equation of a line. We are not again gone into the mathematics of trying to find what is a line of best fit. However, we got this equation of a line through our Google Sheets, and when we look at the equation of a line, so I get it as y equal to m x plus c. Y is my response variable, x is my explanatory variable, and m is the slope of the line, c is the intercept, the sign of the slope. So, if m is greater than 0, then this says that I have a positive relationship. M is less than 0, it says I have a negative relationship. And we also defined what is R square, which is a goodness of fit measure. R square lies between 0 and 1, and if it is closer to 1, we are getting equations of the line. It says that the fit, I am talking about when it comes to a fit, I mean that the line is not capturing the variability in the data as much as in the other case. So, the proportion of variability in my data set that is captured by this line is very low if R square is closer to 0, and it is pretty high if the R square is equal to 1. So, with this we actually have seen the following. In this section we started by looking at the association between two numerical variables . Earlier we looked at association between categorical variables. Okay. Now, in this case the key thing is we first learnt about how we set up what we called as contingency table. Here we started with a scatter plot to look at the association, and then we introduced the notion of relative frequency. Here we looked at row relative frequency and column relative frequency. If they are the same for all rows and columns, then after we said, when we looked at association between numerical variables, we started by looking at a scatter plot. From here we wanted to just have a visual inspection. Within the visual inspection we identified what was the direction, whether it is a positive trend or a negative trend, whether it is a curve or a line, whether they are tight, whether they are clustered or the presence of outliers. These were the 4 things which we looked at. We finally then we said that okay, I am going to focus on a linear association between variables. Now, if I want to know the strength of this association, I introduced 2 main numerical measures which were covariance and correlation measures, and finally, we also looked at how to summarize or describe this linear relation through a equation of a line. We introduced the concept of R square, which is nothing but the goodness of fit measure. So, now if you look at variables, again you go back to your where we started from, and we saw that when we look at variables, I can broadly classify my variables or my data as categorical data, and I can numerical data. So, this portion looked at association when both my variables or pair of variables are categorical. This looked at what happens when pair of variables are numerical in nature.